The next unit is the memory and I/O. The contents of the memory: introduction to memory, memory management, mapping and replacement technique, direct memory access, interconnection standard USB SATA, and memory concept and hierarchy, cache memory, virtual memory, I/O accessing, parallel and serial interface. These are the memory concepts or hierarchy. Memory is a computer system that is organized in a hierarchy to optimize speed, cost, and storage capacity. At the top or register, the fastest and smallest memory units located with the CPU. This is a memory hierarchy design: level 0, level 1, level 2, level 3, level 4, and level 5. 0 CPU register, level 1 cache memory, 2 is a main memory, 3 is a magnetic disk, 4 is optical disk, 5 is a magnetic tape. Is a type of memory hierarchy comprising of magnetic disk, optical disk, and magnetic tape, peripheral storage device accessible by the processor. Internal memory is a comprising of main memory, cache memory, CPU, and the CPU register. These are the memory hierarchy levels: register, cache memory, main memory, secondary storage, magnetic disk, and magnetic tape. The characters of memory hierarchy: access time, capacity, cost, and locality of reference. These are advantage and disadvantage: design complexity, data latency, maintenance overhead, and memory cost. Next is memory management. Memory is a crucial of storing data and managing a multiple process multi-programming system. Efficient memory management is essential to maximize CPU utilization and system throughput. The main memory is nothing but a RAM, is a random access memory. The memory management involves managing the main memory as a multi-programming environment where the operating system resides a part of the memory while the rest is used by the multiple process. These are the why the memory management is required is a track memory usage, fragmentation, minimization, main memory utilization, data integrity. So logical and physical address space is often recognized by the memory units known as a physical address and remains constant. And next one is a static and dynamic loading. It loads the entire program into a fixed address requiring most memory space. A dynamic loads the routines to physical memory only when needed, optimizing memory utilization. The static and dynamic linking. The swapping is involves temporarily moving a process to secondary memory to allow more process to run in a memory. It allows the memory manager to swap out the lower priority process for higher priority ones. These are the techniques in the memory management. These are all the techniques. Fragmentation is when processor loaded and removed from the memory, creating a small free holes that cannot be assigned to the new process. Cache memory is a cache memory working of cache memory. CPU is a cache memory is a fast when compared to the main memory. Characters of cache memory: fast memory, data storage, cost, comparison, processing speed. Working of cache memory is CPU performance by reducing access time, storing frequently accessed data closer to the CPU. Cache hit and cache miss. Levels of cache memory: level 1, 2, 3, and 4. Level 1 is a register, 2 is a cache memory, 3 is a main memory, 4 is a secondary memory. Cache memory applications of cache memory and advantages is a faster when compared to main memory, speeding up program execution, reduce the data access time, improving the CPU performance. Mapping and replacement techniques is a register, cache, main memory, and secondary storage. These are the best example for this. Virtual memory swapping. Overview of virtual memory is a memory management technique that gives application appearance of the large continuous blocks of memory. It's okay. So swapping is a virtual memory. Excessive swapping can lead to trashing where the system spends more time swapping pages than executing process. Causes of thrashing: high degree of multi-programming, lack of frames allocated to the process. Recovery from thrashing is avoid allowing the system to enter thrashing by managing the process allocation, suspend some process to recover from thrashing. Direct memory access is a peripheral devices to transfer the data directly to memory, minimizing CPU involvement and increase the system efficiency. The controllers facilitates data transfer between I/O devices and memory with the minimal CPU interaction. These are the types of DMA: single-ended, dual-ended, attributed, and interleaved. Modes of data transfer: burst mode, transfer mode, and cycle stealing mode. Advantages: these are the advantages and disadvantages of the direct memory access. The I/O accessing, parallel and serial interface. The I/O interface transfers information between internal storage and external devices. Modes of transfer: programmed I/O, interrupt initiated I/O, DMA. Advantages: these are the advantages and disadvantages. The advantages are standardization, modularity, efficiency, and compatibility. Disadvantages are cost, complexity, compatibility issues, and security risk. Interconnection standard: USB. USB is a universal serial bus. SATA is a SATA cable. Serial advanced technology attachment. USB standardized connection for various peripherals, providing a common interface for communication and power supply. These are the USB generation connector: USB 1, 2, and 3.x. Connector type: standard USB, USB mini, micro USB, USB type C. These are the types of USB. Advantages: self-configuring, hot pluggable, standardized interface, and improve reliability. This is a serial advantagement technology of the SATA. It's a better performance when compared to other. It's a fast data transfer rate, smaller cables, low power consumption. Disadvantages: special drives needed, single drive connect per cable, high cost compared to the PATA. Okay. Thank you.